All right, let's give this a go. Try to do this all in one shot here. Oops. Try to do this all in one shot. All right, so we've got x on both sides of the equation. You know, my goal is always to try to get to like x equals something, right? That's our goal, okay, as always. So how can I achieve that? What do we got here? Well, I've got x on both sides of the equations. I really want x on one side. So if I add x here, what's going to happen? That will become 0, right? So I've undone subtracting x by adding x. But I have to add x to this side. So now I'm going to have 4x here. Minus 7 is equal to, and now it's just 5 on the right side. Again, I want to isolate x. So if I isolate 4x, I'm getting closer to that. So I want to undo subtracting 7. So I need to add 7 to both sides. So now I'll have 4x, getting closer, right, is equal to 12. Undo the multiplication, so I divide both sides by 4, and x is going to be equal to 3. Put a box around my answer. Whoopsie daisy. Okay. There we go. Let's try another one. Now I could check that. So 3 times 3 is 9. 9 minus 7 is, well, is that the same as 5 minus 3? 9 minus 7 is 2. 5 minus 3 is 2. Yeah. This one could be done a couple ways, but the standard way would be just to multiply, because that's what that shows. I can't combine inside the bracket, so I can't simplify that. Yeah. Okay, so 4x minus 12 equals 20. This is an easy one now. So that's kind of like the last one. I want to isolate x. I can undo the subtracting by adding 12 to both sides. So that gives me 32, the nice pretty number to work with. So I'm going to undo the multiplication by dividing. 32 divided by 4 is 8. If I check that, 8 minus 3 is 5. 4 times 5 is 20. That does work out. There is another way to do that. We could talk about that later. So like you could undo the multiplication and then do it by dividing and do that right here. You could also do that too. Okay, let me switch colors again. Let's go red. So again, distributive property here, multiplying. So I got 6x minus 4 equals 14. Again, trying to isolate x. So if I get 6x isolated, that's a step closer. I'm going to undo the subtracting by adding to both sides. So 6x is equal to 18. Again, a nice number. So undoing the multiplication by dividing by 6. So x is 3. Should check that. So 3 times 3 is 9. 9 minus 2 is 7. What's 2 times 7? 14. Yep, it worked. Yuck, now we're into the, I don't like fractions. You guys know that. So whenever I see something like this, I want to get rid of those fractions, okay? Who wants to mess around with that? So I got to look at all the denominators. I want to undo, denominators like division. I want to undo all the denominators or all the division in one step. So if I multiply everything by 2, that's going to work for this number and the first one, but not for 2/3. So I need to find out the lowest common multiple of 2 and 3. So what I'm going to do is look at the multiples of 3. We already know 3 doesn't work. What's the next one? 6. 6 is a multiple of 2 as well. So that's what we're going to use. We're going to use 6. So I'm going to times everything by 6, right? Now, as long as I do that to everything, that balances the equation, right? As long as I do the same thing to both sides of the equation, I'm allowed to do that. So you think, well, what are you doing? You're messing it up. You're changing it. Actually, each side is still equivalent. So 6 divided by 2 is 3. 3 times 1 is, okay, 3r. So 3r. 6 divided by 3 is 2. 2 times 2, so minus 4r. See how this is working out nicely? 6 divided by 2 is 3. 3 times 3 is 9. So basically, when I do this here, I have negative r, just negative r is equal to 9. That's not really what I want, right? I don't really want that because I want to end up with r equals. So how can I make this become positive? If I times by -1 to both sides, I'm allowed to do that, right? So -9. Actually, I caught a mistake here. See this negative sign? I forgot about that. So that should have been -9 there, -9 there, negative, and then that means it's positive, right? So, because a negative divide, if I times both sides by -1, it becomes +1. So r is just equal to 1. And we could check that again by substituting. I'm not going to do that, but we could do that. Okay. Let's take a look at number 5. Let's change the color here. Let's go for something interesting. Here we go. See, this is division here. I don't think there's a lot of better choice here other than to undo the division first. So I could times by 2 to both sides. So that would leave me with 2 divided by 2 just cancels the division. So I have x plus 7 equals 10. Oh, this is so easy. X, I'm going to subtract 7 to both sides. X equals 3. I can check that. 3 plus 7 is 10 divided by 2. 10 divided by 2 is 5, so that works. Oh, back to some fractions. I only have one fraction that I want to clear out, so 2/3. If I multiply by 3, I'm going to get rid of that fraction, right? So I'm going to multiply by 3 here. So, and I have to do the same to the other side. Okay. I don't again multiply by 3 here and here because that's already being applied because this is one group as a multiplication. So 3 divided by 3 is 1. So we just have 2 times x minus 6 equals 15. Okay. You know what? I'm just going to use distributive property here. So we have 2x minus 12 equals 15. And then I have to add 12 to both sides. So I have 2x equals, what is that, 27? So x equals, this is not so nice, 27 over 2. I can leave that as 27 over 2. Or I could say that is, I could also say that is, how many times is that? 13. That would be 26, so 13 and a half. All right. So let's move on. Another one of those pretty ones with the fractions. Denominators 10, 2, and 5. So look at the larger denominator being 10. That's not going to work. Oh yeah, actually it will work. Easy. So we're just going to multiply everything by 10. Okay, that turned out a lot nicer than I thought. This isn't too bad at all. All the parts need to be multiplied by 10, right? Oops. So 10 divided by 10, that's just 7, and 10 divided by 2 is 5. So 5 times 3 is 15. Right? Equals 10 divided by 5 is 2. 2 times 3 is 6. And then we just have 20 here because there's no denominator. So this is 26 if I combine it. Again, just got to isolate the 7n first. So 7n, I'm going to subtract 15 to both sides equals 11. And undo that multiplication. 9 equals 11 over 7. Again, you could say 1 and you could say or 1 and what would that be? 4/7. Both are acceptable. Okay, let's move on. So here we have decimals, and you know I also don't like solving with decimals. I like to get rid of those. The way we can do that is multiply by 10 or 100 or 1,000, whatever we need to. We wouldn't want to go further than we need to. Here we only need to multiply by 10. So I'm going to times everything by 10. Okay. So here all the pieces. 10, 10, and 10. Okay, so that's going to clear this decimal out. 8x minus 50 equals 70. Okay, and then isolating 8x first, so by adding 50 to both sides. So add 50 to both sides, that's 120. X equals, what's 120 divided by 8? 120 divided by 4 is 30, and then divided by 2 again would be 15. Okay, I could check that. I'm not going to for time reasons. Let's do one more. Look at this. We've got 2 decimal values. That's the furthest we go. So we could times it by 100. No need to go by 1,000. I'm going to times everything by 100, so this will be 6x plus 2 equals 25 minus 150. Okay, 25x, sorry. Whoops. Good thing I caught that. You know what, I like to have positive coefficient, so if I subtract 6x from both sides, that'll give me 19x. I don't know about the 19x, that's a prime. I have funky feelings about that. And then I add 150 to both sides, so 152. Ooh, I think that's divisible. How many times is that? Let me get my calculator out. 152 divided by 19. Yep, it works out. It's 8. That's it. That's the end of it. Okay.